Today I wanted to talk about Influenza A, which is talk about influenza, I guess, in general, pandemic influenza, which might be better actually, which can be understood from both a Chinese medicine perspective and a Western medical perspective. And looking at influenza in terms of both perspectives, I think reveals some interesting insights. So if you look at the influenza virus at its natural history, you find that it originates from waterfowl. So Influenza A, which is the wild strain of influenza, of the flu, exists in the wild in the waterfowl populations. For instance, in China, if you have all of China here, up in the northwest corner of China, this area that's like Qinghai and reaching all the way up even into Siberia and whatnot in Russia, you have these populations of waterfowl that they go up to these small lakes and things, these swampy lakes and whatnot in the north every summer. And then in the winter time, they travel down to the south and east of China. The flu virus exists in this population of birds that migrate from the northwest to the southeast. At some point in human history, the flu virus was able to jump from the its wild environment, the environment where it lived amongst birds, and causes only very mild symptoms in the birds. It causes them to defecate more frequently, and that's about it. So in the birds, the virus exists in the gastrointestinal tract, and it cycles through their tracts and into the ponds every year. But at some point, this virus was able to jump over into the human population. And some people believe that it may have made the jump from wild animals, from birds, to humans sometime in the 16th or 17th century. And essentially, this is how they propose it happened. These birds that migrate from the northwest, where there are very few people, to the southeast in the wintertime, where there are lots of people, they carried the virus with them. And when they got to the southeast here, you have the Pearl River Delta here in the southeast of China, which is where the you probably have the densest population of human beings in China, in this part of the world. Sometime in the 16th or 17th century, the Chinese people that grow rice in this part of the world, they developed a practice of allowing waterfowl, allowing their ducks and whatnot to sort of help out in the rice paddies by eating insects and other pests, and also to eat weeds that are in the rice paddies there. And this was helpful because it got rid of the weeds in the rice paddies, and it ridded the rice paddies of pests. And then the peasants, or the farmers who were growing the rice, were able to both eat the meat and take those whatever waterfowl they raised, whatever geese or ducks they raised, with them to market. And in the rice paddies, you would have a large kind of area where occasionally migrating geese from the northwest would come and land and mix in with the domesticated geese that might have their wings clipped and were kind of tame. So there were regular reintroductions of various strains of the wild influenza virus into this domestic population of geese that were in close proximity with humans. The interesting part comes, though, because humans would then take these birds with them to market. So initially, it would have been very difficult for the wild influenza A virus strain to infect a human being, and this is still what we find. So if you've ever heard of the bird flu, The bird flu is when a wild strain, a type of Influenza A strain of the virus, is somehow able to jump over into a human host. And when it does, it has a possibility of causing a much more extreme type of symptom presentation, a more extreme type of disease. The wild strain is very poorly contagious. It doesn't spread very well amongst humans, and it doesn't spread easily from birds to humans. In order for people to contract the wild Influenza A strain, they really need to be in very close proximity. So this would have been people that were handling the animals directly, or maybe even children that might be, kind of putting their mouths on the chicken's beak or something while they're playing around with it, or touching the animal and then touching their mouths. And in the late 90s, when the H5N1 strain, which was killing a lot of birds, started to spread through Southeast Asia, and there were over, I think, something like 120 million birds were culled in 1997 in order to stop that strain. There were a number of humans, a number of people that contracted the disease, but it was almost always through close contact with the birds themselves. So at some point, the influenza virus made its way into the human population and was able to, infect on a limited basis human beings. And it's very likely at that early stage of the early kind of phase of its introduction into the human population that it may have had very kind of severe consequences for the person who is afflicted with it. For instance, those people who contract the Influenza A virus today, they're in the case of like the H5N1, it has about a 50% lethality, so about 50% mortality rate. So half the people who get it actually die from the disease. And the reason for that is it's completely unfamiliar to the human host, so we don't have antibodies that are effective in dampening it. And the result of that is similar to what we see with the COVID infection today, where people have a reaction to the virus that causes what is referred to as acute respiratory distress syndrome. Essentially, the lungs, you have the lungs of the person, and here in the lungs you have blood vessels flowing very closely, in close proximity to these air passageways. So you have an air passageway here, and you have a blood vessel there. Now, this is in order for there to be an exchange of gases between the airways, where there's actually air in the lungs, and the blood vessels. So you have a very delicate balance between a liquid, this blood, and a gas, the air in the body. And the body has to be able to both keep the blood in the blood vessels and at the same time allow for a gas to come close enough to it for carbon dioxide and oxygen to be exchanged. When there's inflammation in this area, so when you have this blood vessel, which is just this thin capillary wall, and then you have these alveoli, which are these very, very small air passageways. When there's inflammation in this part of the body, in the lungs, the capillaries will open up. They become more fenestrated, and it's the body's way of trying to flush out whatever toxin happens to be in that tissue, to kind of get rid of it and move it out of there. It's the same response that you get whenever you get any sort of histaminic reaction. So for instance, if you were to just take your fingernail and scratch your arm, you'll see that it becomes red in that area. That's a histaminic response where the blood vessels have actually dilated in that tissue. Or if you were to get a bee sting or an insect sting, the tissue will become red and inflamed and swollen and painful. That's your body's innate immune system. It's not mediated by antibodies. It's the body simply recognizing that there's something wrong here in this tissue. There's something that's dangerous here in this tissue. So cause it to be inflamed, cause fluid to go into that area and kind of wash it out, create pain so that the person immobilizes that part of their body and doesn't move it or afflict it further. So when a person becomes infected with the wild strain of the influenza A, which doesn't tend to pass into the body and infect like the upper respiratory tract, like the nose, the throat, and the bronchi, it tends to actually cause inflammation in the lower respiratory tract, in the lungs themselves. And when we don't have any antibodies to it yet, the body is reduced to resorting to the innate immune response. And that innate immune response is this inflammation of the alveolar tissue, the tissue that lines these tiny airways of the lungs, and the blood vessels. And the result is that blood escapes from the blood vessel and goes into the lungs. This is in the case of the pandemic flu or the Influenza A virus, similar or not similar to, but like exemplified by what happened in the flu pandemic of 1918. So physicians describing the patients that died in 1918 said that when they cut them open and they looked in their lungs actually looked like liver tissue. It no longer looked like lung tissue. It was so full of blood that it looked like a single kind of mass of blood clots. And the patients would have to take increasingly shallower breaths as the reaction to the infection progressed. So over the course of a night, they would be taking shallower and shallower breaths as their lungs would fill with fluid until their faces would turn like a dark blue. And army surgeons and physicians reported that they were unable to distinguish between the African American, more dark-skinned patients and their Caucasian patients, because their skin became so black, so blue from the hypoxia, from the lack of oxygen. So in essence, the infection with influenza A, this pandemic flu infection, is completely different from what happens when we get an influenza B infection, the type of seasonal flu that we're all familiar with. In that case, the immune response is almost entirely mediated by, or a large portion of it is mediated by antibodies in our blood. So we have enough antibodies that are able to recognize and react to the antigenic material of the influenza B virus, so that we get sick. We still have some of the innate immune response. We'll have nausea, which is inflammation of the gastrointestinal tract. We'll have fever. We'll have a headache. We'll have body aches. Those are all innate immune kind of responses to the virus. But overall, our antibodies are able to control the virus enough that it doesn't get out of control. And furthermore, the influenza B virus tends to infect tissues that are less dangerous to us. So because it's become domesticated, so to speak, it will tend to infect the bronchioles. So we'll have a cough in the upper part of our airways. We may have a runny nose. We may have a sore throat. That's all the upper respiratory system, where even if the tissue becomes fairly inflamed, we won't have blood pooling in our lungs. We won't have this potentially deadly acute respiratory distress syndrome picture. So going back to how the virus eventually evolved to the point where it could infect humans, we have this map of China here. We have the northwest of China, where the virus spends its summer, and then we have the southeast of China, where the virus, together with the birds, spends its winters. Here in the southeast, here in the southeast of China, these people here in the Pearl River Delta, they'd be growing their rice, they'd be raising their geese. Their geese would mix in together with the wild geese, and then they would take whatever rice they had grown, whatever geese they could spare with them to market. And you still see these types of markets in China today. You have what are called wet markets. And they spoke a little bit about these wet markets when they were talking about the possible origin of the COVID-19 virus in China. Because in these wet markets, you have large swaths of the population mixing together, and you have various animals from different parts of the country all in close proximity with people. In the case of influenza A, you have a very interesting setup because you'll have the shopkeeper's stall here. So here you have the shopkeeper with their rice or with whatever wares they have, and then behind them, oftentimes they would have a cage, some kind of cage up in the air, and in that cage they'd have their their waterfowl, their ducks and birds and things. And then another very popular thing for people to raise to make money would be pigs. So then behind them in the stall, they would have a pig or two that they also have there for market. So you have people that are run down and tired. You have these birds, as many birds as they could bring, including these ducks and geese that very possibly have whatever the latest strain of influenza A virus. And then you have pigs down below. All three of these in close proximity. And this is a recipe, and you would have this not just once or twice, but you'd have it in a single wet market. You might have it repeated a few hundred, or maybe even if it were a large market, 1,000 times. And in a large city, like if you have Hong Kong or some other large city nearby in the Pearl River Delta, you might have hundreds or even thousands of these markets in a single city. Each one of these kind of setups, you have all of the ingredients for the influenza A virus to do what's called in Western medicine a recombination, which is you'll have one influenza virus, this influenza A virus, and another influenza virus, the maybe tamer strain that is very, very readily contagious but doesn't cause deadly disease. You'll have both of these viruses. You'll have the influenza B from the person who's sick. You'll have the influenza A from these waterfowl. And then down below, this is the crucial part here, you'll have this pig. I think all I can probably make out is, kind of a curly tail and whatnot, but you'll have a pig down below. Pigs are very easily infected by both the influenza B and the influenza A virus. And when that happens, you have a co-infection of the pig. And now I think to understand why that's important or what can happen there, I'd like to talk a little bit about the life cycle of the virus itself. Is everyone with me so far? Okay, great. So you have the virus is inhaled or it comes into the upper respiratory tract or the gastrointestinal tract via contact or via some aerosol droplets. These individual viruses, they consist of a single phospholipid bilayer, a single piece of the cell membrane from their host cell, and that then attaches with the larger new cell that it's infecting. In order to dock with the cell, it has a couple of molecules here. It has a hemagglutinin and a neuraminidase molecule, but essentially those are the molecules that allow the virus to latch onto the host cell with its nucleus and all of its other organelles. It latches onto it, and then the genetic material, this very simple genetic material that's inside the virus, is able to enter the cell, and it migrates to the nucleus where we have our double-stranded DNA and our single-stranded RNA. These smaller pieces of viral RNA enter into the nucleus and essentially take over the genetic machinery of the cell. And they tell the cell to make lots and lots of these same genetic codes, and also to make the proteins that the virus is going to need on its surface. So it'll make this hemagglutinin, this H protein, it'll make the neuraminidase, this N protein, and there are a number of other proteins that the virus needs to survive. All of these proteins that are produced by this cell, which is infected and is essentially dying at this point, this infected cell in the respiratory or gastrointestinal tract, all these virus proteins and genetic material, it will all kind of migrate to the underside of the outside of the cell, so to the basement of the cell membrane. And at a certain point, the virus then signals this human cell to lyse. And for individual smaller pieces of this cell membrane to pinch off and form these smaller kind of viral packets with all these pieces of genetic material and proteins that the virus had instructed the nucleus to make. When that happens, only a very small number of these viruses are actually viable. So from a single cell that creates, I don't know, thousands and thousands and thousands of these smaller viral particles, what are called, often referred to as virions, because many of them they're not even true viruses yet. They may be missing proteins, they may be missing genetic material that are needed to reproduce. Most of the virions that are produced are non-viable. They can't infect another cell. But many of them, some of them, enough of them, are able to, they do have all of the components that they need, and they're then able to go and infect another cell. Now, what can happen in this scenario we talked about with the rice farmer, his chickens, and the pig is two different viruses, the Influenza A virus, which isn't able to easily infect people, and the Influenza B virus, which will infect a single cell. When that happens, you'll have this Influenza A here, this Influenza B here. Both of them will infect a single pig cell because pigs are able to become this kind of, because they're easily infected by either Influenza A or B. A single pig kind of respiratory or gastrointestinal tract cell can become co-infected. When that happens, the nucleus will produce both types of proteins for both of the types of viruses. And when the virus instructs it to lyse, you'll get viruses that will contain some Influenza A and some Influenza B material. So you'll have basically a new kind of hybrid virus. And what is very dangerous is when you have a brand new type of virus that is very contagious. It can easily infect and be easily transmitted from person to person, like an Influenza B virus, but has a proclivity to infect the lower respiratory tract and is also very unfamiliar to the human humoral immune system, to the antibody system of the body, like an Influenza A virus. And that's how you get a kind of a pandemic strain of the influenza. That's when the wild strain, a new strain, is able to kind of jump over into the human population and kill large swaths of people, like we saw in 1918, where some people say it was somewhere around 50 million. Other people say it could have been as high as 100 million people died of this this novel Influenza A strain. That's a kind of co-infection. So I wanted to give you that background on the influenza virus so that when I'm talking about the Chinese perspective, some of the metaphors and things that they came up with are, I guess, a little better, easier to understand. When the Chinese, again, it's sometime in the 16th century or so, there was a big shift in terms of the way people started to think about disease in general in China. And it probably happened already in like the 13th and 14th century. There were a lot of these very strongly epidemic diseases that were killing large swaths of large numbers of the human population and were more infectious than earlier diseases had been. But the Chinese had a name for these types of diseases even as far back as 2,000 years ago, and it was Li. So this Li here, you have the illness radical, which is this part here, which was originally written like a bed with a person on it. and then it showed their kind of like sweat marks. So, or these lines may have indicated that they were agitated or unwell, but this was the form of a person kind of on their side, I guess. These were the marks of sweat, and then this part here represented kind of a bed or a raised platform that they were resting on. This other part here, this part, this character, is 1, which means 10,000. And it's an interesting kind of number. Both the Chinese and Native Americans had a particular word for 10,000. That was, we say 10,000, but they had a single word that meant 10,000. This word here, 1. So that word 10,000 together with the sickness radical equals this word li, this Chinese word or concept li, which is pestilence. And the concept of pestilence is like one where lots of people are dying, and it's a particular type, as I'll explain further, it's a particular type of disease pattern that's described all the way back in the Yellow Emperor's Classic of Chinese Medicine 2,000 years ago. So this character here, this 1, it may simply refer to the number of people that were killed by it, but I think that this part of the character has another level of meaning as it was used. And that is, strangely enough, this character for 10,000 derives from this oracle bone script, which was written like this. And another way of writing it was like this. And this is actually a picture of a scorpion. So somehow this character for scorpion came to mean 10,000. I think it's very interesting because scorpions are kind of I don't want to say they're unique, but they're a very unusual creature. They're about 500 million years old. So they were, or the individual insects aren't, of course, but the scorpions were around 500 million years ago. So before there were even dinosaurs, there were scorpions very similar to what we have today, scampering around on the earth. They're spread throughout the biosphere. The only continent where you don't find scorpions is Antarctica. They'll exist anywhere from up to 12,000 feet at altitude, all the way down into sea level jungles and things. These kind of ancient creatures have a very low rate of reproduction. So unlike other insects that produce lots of eggs and produce lots of young, scorpions tend to live in a single place. They sort of hide under like a rock, or they live in a single burrow, and they produce just a few young, and they actually carry their young on their back, and will kind of walk around with these pale little scorpions on their back as they're growing, I guess. The other thing about scorpions is they, unlike other animals for the most part, they have this ability to hibernate, which isn't dependent so much on cold, but is really dependent on dryness. So they'll be in this little, this small area where generation after generation of these scorpions will be living, and they are able to estivate. Estivation is the process by which they almost completely dehydrate. They go into this dry state of suspended animation, and they can remain like that for years or even decades in this kind of frozen suspended animation state. And then when the humidity gets high enough, they will kind of wake up again, but again they remain very still. They might not move around at all. They'll remain there until their prey passes in front of them. They'll latch on to their prey, and they'll then inject the prey with this poison, which both paralyzes their prey and starts to digest their prey in in their own body. It's kind of a digestive neurotoxin that's injected into the prey. That whole metaphor, this metaphor of the scorpion latching on, grabbing, and then injecting poison into its prey and digesting it, is very similar to what you see with the virus and the cell. So you have this virus which has these molecules on its surface that essentially latch onto the cell, and then of course it injects this genetic material into the cell, which takes over, kind of paralyzes the normal workings of the cell, and then starts to, in a way, digest the cell to make more of itself. The other way in which scorpions are kind of similar to viruses is viruses as well. They tend to survive or exist best in these kind of cold, dry environments. So in the same way that the scorpion can kind of hide in a place and remain in a state of suspended animation in a cold, dry environment, a virus, after it's left the body, is much more easily transmitted in cold, dry weather, which is why with seasonal flu, it tends to be worst in the colder, drier months of the year when, coughing or something like that, these aerosolized droplets that contain these individual viruses can float through the air and make the journey from one human being to another without dying or kind of falling apart there. So this notion of the scorpion, of this character Li, this notion of Li, of this kind of scorpion being emblematic of this type of viral or pandemic disease, I think is very fitting. For the Chinese, at least in Chinese classical medical understanding, the almost all diseases were the result of there being some kind of disorder in the natural cosmos. And it wasn't necessarily like a disorder in terms of the environment or something that was going on with other animals. It was very often thought of and referred to as a disease caused by some aberration or dysfunction in the way the seasons, the natural progression of the seasons, were supposed to take place. So they talk about Shi Bing. This character Shi means time, and this is the character for Bing, or illness. So the idea was that if any particular season had too much or too little of the quality that it was supposed to have, the result would be that illness could then enter into the human population. And the classic example of this in terms of pestilential disease is when in the winter time, when things are supposed to be cold, and when the yang qi is supposed to be completely contained and held inside by the yin energy. If that yin energy isn't strong enough, if the winter isn't kind of cold enough, then the result could be that when the spring starts to emerge, there would be too much of this kind of yang energy, and it would then cause the type of disease that we think of as like a pandemic flu, or even in the case of COVID, it would be, again, this kind of pandemic type of disease. So amongst the Chinese medical community in China, there's an understanding of COVID as having emerged in 2019, 2020, as a result of they had a very unseasonably warm winter and spring. And that's when the COVID virus kind of first started to emerge and become prevalent in China. So even today, in terms of looking at that disease, it's couched in this notion of some sort of disharmony in the natural environment. When you look at the flu virus, its actual kind of natural history, you have, again with China, you have this continuum between the northwest and the southeast. In Chinese cosmological understanding, the north and the west, that's the most yin part of the geography. So in the north you have winter, in the west you have fall in terms of time. And here in this part of the world, you have the most yin energy, which is why the ducks and geese go there in the summertime when it's hot. They go up to here where the kind of yin is stored. But then in the wintertime, they come down to the south and east. You have the rising sun of spring, and then you have the sun high in the sky of summer here in the southeast. So you have this natural kind of polarity, this continuum between the northwest and the southeast. Somehow this virus, which should naturally kind of be contained in the northwest, this is where the influenza A virus is sort of made to kind of thrive in these lakes up here. But because of this particular way that humans are interacting with their environment, creating this population density, bringing wild waterfowl together with domesticated waterfowl and pigs all together in this dense population of humans. Here in the southeast, the virus is able to jump over into the human population and cause disease. So in the Chinese classics, in the Yellow Emperor's classic, it talks about how this Li Qi, this pestilential illness, is the result of the energy from the energy of the kind of the northwest in the cosmos somehow becoming weak, and as a result the energy in the southeast becoming too strong, and you have this yang energy emerging or bursting forth in the human population. When you look at what goes on in the lungs, how people die from the influenza A virus, from a pandemic infection, it's very much a picture of that, because you have the lungs, which are the metal organ and which kind of epitomize fall. They kind of epitomize subduing and collecting and bringing things back into the body. You have this lung tissue that forms this alveolar epithelia. And then you have these blood vessels. Now these blood vessels that are in the lungs, they go directly to the right chamber of the heart. So the heart is pumping its blood, its warm, hot blood, into the lungs so that it can receive oxygen and give off carbon dioxide into the air passages. The heart, of course, is the organ associated with fire and with summertime. So the season that's associated with the heart is summer, and the element that's associated with the heart is fire. So here in the lungs, you have this close proximity between the heart blood, which represents fire, and the lungs, the air, which are kind of represented by metal. So in a way, right here, you see this kind of polarity between the northwest and the southeast, but inside the body. And just as in this geographical picture, where you have a disharmony between the northwest becoming weaker and the southeast becoming stronger to the point where things tip and the balance is lost, in the human body with influenza A infection, you have inflammation, you have this heat and sort of histaminic fire happening here, where the blood vessels become more porous, the lining of the alveolar sacs tends to open up, and then you have this heart blood entering into the lungs and causing the person to drown in their own blood, essentially. I hope that point makes sense in terms of this larger kind of picture here. How are we on time?
We are at 42 minutes.
42 minutes, okay. So I wanted to that's pretty much as far as I wanted to go with this. But I guess I'll just take a moment to kind of try to summarize the points or the ideas that I've made so far in the lecture. Essentially, in the early Chinese cosmological mind, they weren't aware that there were viruses. We didn't know about viruses until just the previous century, the 20th century, when we were able to somehow create filters that were small enough to separate out viral material from the other kind of healthy tissue. But they were somehow aware of the themes of what was happening in the world. And so just as we now understand that viruses can kind of lay in wait and kind of remain in these sort of pockets of the macrocosm, and we can come in contact with them and suddenly be struck with an illness, the Chinese were able to see that kind of pattern, and metaphorically or analogically, they saw it as similar to getting a scorpion sting. You can imagine if you just reach your hand into the wrong place and suddenly the scorpion latches onto you, injects its venom into you, and you're suddenly afflicted with this like pain and heat, and the tissue becomes inflamed. So even though they didn't think that an actual scorpion was causing the disease, when they saw these types of this type of acute deadly illness affecting patients, for them it was like corollary or analogical to getting a scorpion sting. And then for them too, they were able to kind of see the pattern of energy in the human body and compare that to the pattern of energy that they saw out in the geography and the cycle of seasons. And from that, they were able to kind of almost understand that what was happening in the body was also somehow a reflection of the disharmony that they could see out in the larger world, in the kind of natural pattern of geography, but maybe more importantly, the natural pattern and rhythm of the seasons. And surprisingly or unsurprisingly, many of the things that they kind of thought, for instance, that this pestilential disease was somehow a reflection of this axis between the northwest and the southeast being in disharmony, those in fact kind of seem to be borne out by what we know about at least the case of Influenza A virus, where it is kind of reflected in its natural history, in that this movement of birds from the northwest of China to the southeast of China, and the introduction of the virus to humans in the southeast, fit with that pattern of understanding the human body.